Hi everyone, welcome to the next video. Today we're going to be installing the safeties and controls that make sure that the boiler is always operating well and it's operating safely. So one of the things that I wanted to bring up is one of the biggest safety problems with a boiler like this is the possibility of explosion. So when a boiler explodes, it's not quite what most people think. What ends up happening is you have water under pressure will always boil at a higher temperature than it would if it was just under atmospheric pressure. So if you get into a situation where the pressure in the boiler is rising and you keep increasing the temperature of the water, you get to a situation where the water can be at 230 degrees, which is well above boiling. And if something were to happen, like say the side of the boiler cracks because the pressure got too high for it to contain, then all that water in there will instantly flash to steam. And when that happens, at atmospheric pressure, liquid water to steam will increase its volume by 1,700 times. So if you can imagine, for every gallon of water in that boiler, suddenly you would have 1,700 gallons of steam in an instant. It is, by all definitions, an explosion. And they can be very violent, they can be very dangerous. So the primary concern is making sure that that can never happen. So what I'm installing right now is the two pressure trolls which operate off of pressure. And you saw me install those little pigtail pipes there and put some water in them. That keeps the steam from actually touching the control, but it can still sense the pressure. The one on the left is the normal operating control. It will make sure that the pressure in the boiler sits below 2 psi, and it will reset itself. If the pressure, if the pressure goes up to 2 psi, it'll shut the burner off, and then if it drops down to half a psi, it will turn the boiler back on. And that's a normal operating control. Now, if I sized everything correctly, in theory, that should never even trip. It should always turn on and off just by the thermostat. But if I have, a stuck air vent or something like that, the system will still work, but it will operate off that pressure troll, hit pressure, and then drop back down. That's not a terrible thing. The one on the right is set to 5 psi. Now, if it ever gets to 5 psi, something is definitely very wrong. I would have something, either the pigtail may be clogged on the operating control, it's letting it get too high. Something is wrong. So that actually has a manual reset on it. So if it ever trips at 5 psi, someone will actually have to physically come down and push that button to reset it, which, means that someone will have to figure out why that tripped. And then next I'm going to install what are called low water cutoffs. So the first one is going to be a float style low water cutoff, and it has a little float in it, and if the water level gets too low, which is above the minimum level of the boiler but still fairly low, what it will do is shut the burner off until the water until the water level returns and lifts that float up. And then there's also a manual reset low water cutoff that's an electronic probe type low water cutoff. And again, it also has a manual reset, so someone would actually have to physically come and push the button to reset it and figure out why that water level got too low. Also, off the front of the low water cutoff, once I get this installed, so this is the float type low water cutoff. On the front of that, off those T's, is going to be the sight glass, so that you can always, at a glance, see where the water level in the boiler is at. And it should always be within, there's a normal operating range that it can go up and down within and still be fine, but there is a desired, ideal water line for that boiler. So as I get all this, doped up and tightened together and installed, I want to mention that one of the things I read somewhere said that the invention of the pressure relief valve for any pressurized vessel, you'll see them on water heaters, any pressurized tank, any boiler, they all have to have relief valves. And someone actually estimated that it is possible that, at least in America, the invention of the pressure relief valve possibly has saved more lives than the invention of penicillin. And it's not something I'm too surprised at. Back in the day, boilers were exploding in America at the rate of about 3 a week before the invention of that valve. And some were pretty horrendous. I mean, there are some steamship explosions that have happened that killed a couple hundred people at a time. Um, there was a boiler explosion in New York, I forget the year, but late 1800s, that it was a very, very big boiler feeding steam to multiple buildings. And it took out a whole city block. I think there were at least 1,000 people that died from that one explosion. It was quite a problem, and there weren't really any regulations back in the day about what you had to have. So, um, a couple insurance companies and a couple manufacturers got together and figured out some standards by which they wanted to make sure everything was designed to, and that everything had to have an operable pressure relief valve. Everything had to have certain design criteria, like only running systems at 2 psi or less. Some of the old systems were running at 60 or 70, even 100 psi, which is incredibly dangerous. You just really don't even need um, pressures that high. So, um, anyways, that little bit on the history of that for you. Here you can see I'm installing the sight glass, and that is a glass tube that just fits in between those two outlets and gives you at a glance, tells you exactly where the water in the boiler is. And then on the right here, the last thing is going to be that probe style low water cutoff. You'll see me install that kind of in that bottom right hole there. And of course there's also one hole that isn't used in this particular setup, so it needs to be plugged. So that's the probe for the low water cutoff, and then it's got a little electronic head that fits onto it. And here you can see me installing that plug, get that tightened up, and that'll about do it for all the controls. Yeah, and then the relief valve on this one goes on the opposite side of the boiler. I didn't move the camera, but you'll see me go over there, and that's what I'm doing, is installing that pressure relief valve. So if the pressure in the boiler ever hits 15 pounds, then that relief valve will open. The boiler itself is rated at no more than 15 psi, so that's why the relief valve is set to that. But the testing ensures that no matter what, this boiler should be safe. It should not break or crack or anything up to 30 psi. So the level of redundancy on all the design and all the controls is pretty high. I mean, you have two pressure controls, one that is a manual reset. You have two low water cutoffs, one that is manual reset. So if anything goes wrong, it's going to be very unlikely that you ever come close to reaching the level of an explosion. You would have to have your operating control fail, your high limit control fail, your relief valve fail, your low water cutoffs fail, both of them. All of those things would have to happen to keep the burner firing and cause a situation where you could conceivably have an explosion. So the standards now are geared towards just huge amounts of redundancy, huge amounts of safety. So, and there are other safeties as well. There's a draft switch and a flame rollout switch for the burner that have to be closed to make sure, so if the boiler's not backdrafting, the flame's not rolling out, anything like that. And all of those are wired in series, so everything has to be working for the boiler to even fire. So anyways, that's a little bit about all the redundant safeties and the controls and how they work on this boiler. Hope you guys enjoyed the video, and if you have any questions, you can email me at templeaaronboilerreplacement@gmail.com. Hope you guys have a good day.